Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, stories, and connections from all flavors of Passive House, check out the articles, videos, and more at passivehouseaccelerator.com. Sign up to receive regular updates about events, join the community forum, and of course, attend the weekly online Global Passive House Happy Hour. Now, here's this week's Passive House podcast. Well, welcome back to another episode of the Passive House podcast. I'm Matthew Cutler-Welsh, coming to you from Auckland in New Zealand.
And I'm Zach Semke, coming to you from Seattle.
And things get pretty hot here and dry. It's the middle of summer for me, but I'm guessing, looking at you, Zach, you got the beanie on there. It's a little bit cool in your part of the world.
It is a little bit cold, and we've had record rain in January for Seattle, so it's been really, really wet. Today is beautiful, though. The sun is shining, the sky is blue, so I'm looking forward to better things to come in 2021.
In more ways than one, yes. And things are looking up. This interview from today, I actually recorded earlier in 2020, and it is a bit of a time capsule, but still very relevant. And having got back in touch with Brett, who's the guest on the show, fantastic to hear that things have improved and got really busy, and his business is growing. So let's jump into introducing Brett Seriani, who is our guest on the show today. Brett believes that all buildings should be comfortable and healthy, and he's a strong advocate for using sustainable materials and making buildings economical for his clients. He attributes some of his affiliation with natural elements and also his attraction to sustainable design to growing up in Vancouver, BC, although he now lives and works just outside of Melbourne in the Australian state of Victoria. Before becoming a certified passive house designer, Brett trained and qualified as both a structural engineer and an architect, which is quite a lot of training and very impressive. So he's a bit of a powerhouse of experience and knowledge, and very well placed to offer a whole range of technical design services through his company, which he operates now just out of Melbourne, called Seriani Designs. And the mission of his company is to design buildings which have a minimal impact on the environment, that allow the owners and occupiers to live in comfortable, healthy, and sustainable homes throughout the entire life of the building. So, very worthy guest. I started out by asking Brett how he got started in the design industry in the first place. Alrighty, so thank you, Brett, for joining us. Really appreciate your time.
Yeah.
Can you start by giving us a little bit of a background into your backstory? How did you get into the building industry in the first place?
Yeah, so I started out in Canada in the mid-90s. And started out in architectural design at my beginning sort of stages of my career. I practiced there for a while, and I sort of progressed over more into a structural engineering aspect after a while, just because there's a bit of a downturn in the residential industry during that time frame. And I went back to school, retrained myself, did my structural engineering, and got out and practiced ever since. So
originally you trained as an architect?
Yeah, so I did architectural design, and then later went back and did structural engineering on top of it. Yeah.
That's a good chunk of time at college.
It is. Yeah, student loans to prove it.
Yeah, nice.
But yeah.
And then did more later on. You've done a master's on top of that, right?
So I'm currently doing my master's. So I'm finalizing a master's in engineering. I'm focusing in on sustainable structural design, where the main focus on my thesis is around sustainable design within the Australian built environment and the application of passive house to that for the operational side. So fundamentally, what I'm looking at is integrating a LCA with inside of the structural perspectives, properly choosing your materials as well as your structural design, and then looking at passive house on the operational side. So integrating that into a full system, and having that as more of a, I guess, proven process on how to do things better with regards to the actual built environment.
So when you say LCA, looking at the structural side and then the operational costs, are you basically looking at money spent up front on the structure of the building and the impact that has potentially on the running costs of the building?
So I'm actually looking at the embodied carbons, so full life cycle assessment on that. So I'm looking at the differences between your main structural components that we'll use is timber, steel, concrete, masonry, glazing, and that sort of thing, and actually looking at the embodied carbon of that and what's a better solution in order to optimize the actual structure so that you're reducing that embodied carbon properly. Everybody defaults towards concrete and steel for many structures. The advances of CLT and engineered wood products that are out there now is now challenging that, which is a good thing in my opinion. Engineered products has been around for a long time. The concept of glue lams and LVL and that sort of stuff, they go back, decades and decades. But it's now getting a good revitalization at this point because now people are starting to really look at the sustainability of the buildings. So,
where is that coming from? Who is concerned about embodied carbon apart from external people who are worried about the environment, but who in the process of developing and financing a building is genuinely concerned about embodied carbon in Australia?
Yeah, so when it's crossing over, when you're looking at the embodied carbon, you're actually looking at the material properties for it, which somewhat translates over into the overall operational performance. So when you look at the energy used in order to heat and cool a building, your materials that you're using have basically a fairly significant effect on how that is actually performed. So if you're looking at the types of materials that you're going to have, that will have a significant change with regards to how it operationally performs. So from my perspective on it, it's going to be back to the developers, builders, and I'm pushing it from an structural engineering perspective as well to have an involvement with inside of that in the decision-making process.
So you're talking about the operational costs, so making the building more efficient, so it costs less to run, which is a financial saving, but also if your energy system is largely powered by brown coal and fossil fuels, so there's a saving in the ongoing operation of the building. What about the embodied energy at construction stage? Is that of a concern? Are there any financial levers that are impacting decisions for the developer at the moment?
Yeah, so when you look at the construction stage of your LCA, obviously, going between the use of concrete or steel or timber, all of those have different sort of labor components and external plant and different other materials that are used in order to construct the structure. So that has a cost implications as well, and that's getting looked at.
And does that translate to real costs in the Australian
translates into real dollars and savings, actually? Yeah.
Right.
Yeah.
So because are there, what I'm getting at, are there policy levers or artificial drivers in the market right now in Australia that are pushing people towards more sustainable material selection?
Not on a policy sort of level. I think eventually over time it's going to be, this is basically just maybe I can put it, hypothesis, if you will, that over time the sustainable and not necessarily greenwashing, but green sort of adoption rate on buildings is going to go a lot more quicker, right? The adoption rate on it is actually going to pick up quite a bit because people are looking at their energy consumption of electrical buildings, and what's going to translate down also into the materials for it. So, yeah.
Do you remember when you first heard about Passive House?
Yeah, I do. It was around 2018, November, somewhere around there. I was at a Building Designers Association meeting here in Victoria, and this
is Victoria, Australia, not British
BC. Yeah, so here in Melbourne, and the discussion, it was a CPD session, and the discussion was around sustainable buildings. And within that, there was two speakers, one Claire Perry, and then another one, Simone Schenkel. And I think even Cameron Monroe was there as well, and discussing their projects. And they just discussed Passive House, what it was, and how it evolved and how it came to place, and their projects that they were doing. So when I heard it, it was like a light bulb that went off, where it is the way that buildings and structures should be designed. It's based around physics. It's based around proven methods. It's tested. It's not a checklist on how to do something in a sustainable way. It's actually tested, and it's a proven method of doing it. And that just resonated with me. It was brilliant. And I just got on that journey ever since.
So I'm kind of surprised, because that's quite late on in your experience and your journey, right back through to Canada, and what was it?
94.
Engineering technologist, and being a structural draftsperson in Canada. You hadn't come across sort of philosophy back there?
No, we didn't actually. So most of the stuff that once I got out and finished my structural engineering, I worked for a consultancy company, and the types of structures in which we did really weren't within inside of the residential or the commercial space. It was more in public structure works, bridges and piers, that sort of thing, where did more of an investigative works around fire investigations and restoration works and that sort of thing. So it was a little bit different from the types of works that I was doing. Plus, we did a lot of stuff inside the utility sectors as well.
Right. Yeah. So that was 2018. You heard about Passive House. What was the next step for you?
Both feet jumped in. It was it was literally this massive realization that this is how it has to be. So because when I first started in my initial sort of conceptual days of wanting to participate in architecture and engineering, is that I wanted to design sustainable buildings that were good for the environment and pleasing and that sort of stuff visually as well. So and it just resonated with me to go back into what I originally wanted to go over and do in my career. So when I got to Australia, I was participating in more project management work, and that seminar was like a kickstart for me to reinitiate everything that I had from the beginning of my career.
Nice. So getting back to some of the creative side of things?
More of the creative side of things, yeah. More design works, yeah.
But still having the ability to analyze and calculate and use your knowledge of physics.
Exactly.
So, jumping forward to today, you got a couple of things on the go, but primarily your practice, your design practice.
Yep.
What are the main services that you provide?
Yeah. So main one is obviously passive house design. From a residential perspective, as well as structural engineering and consultancy around that. So,
yeah. And are you working a little bit in the prefabrication space as well?
Trying to get into that a little bit. Looking at it, there's another individual that he and I have been going back and forth with regards to some discussions around potentially looking at doing prefab passive homes and looking at what we can do with inside of that space.
What's the attraction there?
Looking at regards to population growth and urban sprawl and a few other things that are coming up, sort of both have the philosophy that the housing industry is going to go through a large boom, and the generation which is coming up as the buyer generation is not really going to be looking for the larger block sort of project home. I guess their philosophy will be a smaller sort of style of home that's going to be comfortable and economical and efficient to run. So we're looking in at, I guess, smaller homes that are Passive House certified that we can deliver onto smaller lots and that sort of thing. So yeah, it's early discussions around it.
Yeah. Now, tell me about the impact that a structural engineer has on the envelope of the building, because this is something I've thought about.
Yep.
The structural engineering has to be done because it's critical for holding the building up.
Yeah.
What are some of the ways that a structural engineer who doesn't know about passive house or about some of the intricacies, what are some of the ways that they can kind of stuff up a building?
Yeah, well, ways of stuffing it up is your thermal bridging, right? Relying upon bracing for vacuum forces, that sort of thing, as a generic sort of thing. You can get away with actually doing a different sort of design, portal frames, as a prime one, using larger timber sections in order to sort of develop larger spans inside of the structure. But you got to remember that with the wall thicknesses that we're trying to achieve with inside a passive house, most of it's to accommodate the thermal insulation. While you're looking at like an R4 or an R6 sort of wall, where you're 150 to say 230 mil thickness of a wall. Well, you're not going to have your stud walls actually developed up to that sort of form of thickness. So you can go to a structural sort of property with portal frames, change that to basically make your stud walls non-load bearing going forward, and try and hide out all of your thermal bridging connections and have revealed connections, that sort of stuff inside of it. So looking at those sort of aspects of the actual overall structure can help out on the actual building design.
Are there ways that the process needs to change to allow that to happen more naturally rather than the standard design through the construction process that we see today?
So for me, I'm a big promoter and supporter of integrated design teams. I think at the very beginning of the onset, once the client, engages a design professional, whether that's the architect or the engineer, I think that team needs to get together. And that team, personally, I believe, should be the architect, your structural engineer, and also your builder, right up front, and saying, okay, look, this is the concept in which we're trying to achieve. And you start building that team at the beginning, working together in order to develop the solution for the client. And having that together sort of eliminates the staged milestone sort of approach with regards to actually doing things, where you can start integrating your conceptual designs together, start preliminary looking in at any sort of building materials, different systems, connections, how it's going to get built, how it's going to get delivered, any other sort of constraints with regards to the project, that can get identified up front, rather than going through the design build or design procure build sort of process, which is normally sort of positioned with inside the market currently, or even worse, where you have a conceptual design team and then a detailed design team, and it's handed off to completely different people. So,
right, and they come to you as a structural engineer and they say, just make it work.
Yeah, pretty much.
Yeah, instead of having that integration right from the start. Yeah. Is there a limit to the size of project where that makes sense? So when I think of integrated design process, I think of large, complex buildings. But should that similar process happen in all types of projects, all sizes?
I do, yeah. So I'm working actually with another architect currently. She's also a passive house designer, and we're right at conceptual stage for a project down in Germana. I got another one that I'm just quoting in today as well for New South Wales, also right at the very beginning of conceptual design stage. And we're able to go back and forth on an open communication to discuss how we're actually going to solve the layouts, the designs, the structural members, how we're going to address the insulation, airtight barrier, weather type barrier, etc. And then start looking at those details up front, so that when we start looking in at doing the submission for your preliminaries, regards to the Passive House Institute or your certifier, that we've got something that's there that's feasible up front, and then we can carry that through to the detailed design stages.
Where do you see the most common tricky points are in the thermal envelope with regards to thermal bridges?
For me, it's looking at the connection into the foundations from the flooring. Getting over the concept that you're connecting down into a large piece of concrete and that's going into the ground, and then you've got a big thermal bridge going directly through that. So changing that methodology with regards to how you're doing your flooring and the types of a foundation should be looked at up front. So now with that, you have to have a little bit of extra cost up front, getting some kind of an indication geotechnical report that's there for the soils, because that obviously affects the types of foundations that we're going to design for the structure. But if we can get away with doing, an edge beam or a rim beam or, a floating slab or ideally, no concrete, and just using timber as foundations with regards to a lot of things is, preferable. It's the best way of doing it.
So you think going to a suspended timber floor is often a better alternative than a concrete slab?
Yep. So for me, I try to do most of the structures without actually doing the waffles, pods, or slab on grade sort of situations. You can get away with strip footings and then just floor joists that are insulated underneath. It's not a difficult system to go off and do. Sure the details are done.
And where you do have to have concrete, either for site requirements or for client choice, do you have a preference of trying to insulate underneath the slab, or, like you say, doing a floating floor on top of the slab and just kind of writing off the slab?
Yeah, definitely try to insulate the slab if we have to, and then also try to decouple it as well, so that the insulation that you do have to use is either minimized, or you're actually minimizing the actual thermal transfer through the slab in itself.
Yeah. And what about other details like balconies? Do they often cause a bit of an issue for people?
Depends upon the connections on how that's done. Obviously, balcony out there, you got, steel rods or, steel connections going directly into the structure. That's a bit of a concern. But that's something that does have to get looked at. You can get away with different nailing plates and a few other sort of mechanisms in order to basically support up the structure properly.
But like you say,
decouple it from the existing building.
Yeah. And as you said before, there are solutions out there. It's just a matter of utilizing those and slotting them into the design process at the right time, as early as possible.
Yeah, and you can have there's thermal isolators and thermal donuts that you can have. That just is a break in between the structural members and the rest of the wood as well. So they are available.
Where do you see things heading in the building industry in terms of energy efficient design and particularly passive house in the region that you're in around Australia? Where's the market heading at the moment?
Yeah, I think the uptake on passive house is it's on a steep curve right now, which is good. I think in the next 5 to 10 years, we're going to look at probably a different style of a code overall for our building industry. and the adoption, whether or not maybe not full passive house, but more towards moving to, I guess, towards the low energy sort of homes is now going to be sort of standardized with inside of most of the designs and the codes going forward. So the new code that's come out, I guess it's somewhat addressing things, but it's a long ways to go. When we look at other countries and cities that have adopted it, notably you look at the step code that was done in Vancouver. It's a huge step forward, with regards to how to do things properly and give initiatives to the builders and the designers, and also the adoption of passive house with inside of the buildings going forward. So I think following that form of a model would be something in which, personally I would like to see Australia actually trying to adopt as well. It's a better way. It has some initiative towards it as well.
So do you think the momentum that's sort of an eternal momentum at the moment for people who are just passionate, is that enough, or does it need more of a drive from policy or from some sort of mandatory measure?
I think it needs a drive from policy as well. Now, AFA here, they're fairly good, and to my knowledge, they're trying to work in with the governments and different bodies as well.
So that's the Australian Passive House Association. Yep.
And there needs to be, I guess, that kick from a government at some point with some form of a policy in place with regards to, if all new buildings going forward will have this form of a requirement. But that has to happen in order for it to have a huge kickoff. There's most builders will only build to a minimum standard, which is unfortunate when it comes into your project and your volume-based homes. And that's a lot of things that are still happening with inside of Australia, where you still have those big developers, and they're only going to build towards that because it's a cost associated to it. So what we need to do is start building more energy efficient homes and start looking at the costs associated to them, both from the construction perspective as well as the operational perspective as well, and start promoting that, saying, look, it might cost an extra 5 to 10% up front, but the health and operational costs going forward, here are the benefits. And you'll start seeing people starting to maybe demand it a little bit more. And then also just, you got to promote the hell out of it in order to make sure that it comes across. So, yeah.
Well, you're certainly contributing towards that, and I hope that I look forward to your thesis, hoping to push that direction as well, of people looking at the life cycle and the running costs as well.
Yeah, thank you. Yeah, it should be good.
Where? So you mentioned doing work across New South Wales, and I guess because you're design work, do you have any geographic limits on where you serve clients across Australia?
No, I don't actually. So with Engineers Australia, registered through them, so that allows me to work across the country. And with building design, it's still open as well. And then obviously passive consultancy on that. That's also national and international if needed.
Yeah. PHPP is pretty global. So
much,
no boundaries there. So where can people find you, Brett?
Yeah, so they can head over to my website, which is www.serianidesigns.com. And then also the traditional social media platforms and Facebook, LinkedIn, and Insta and Pinterest, House.
We'll link those up so that people can find you. Hey, thanks for your time, and pleasure to chat. You're doing great work, and I really like that connection between the structural side, which is so integral to the building envelope as well, because it often that's where the structure is. So it's great to have people like yourself who are thinking about those aspects combined with the thermal performance.
Yeah, and to me, when I saw it, it was like a natural fit, because as structural engineers, we're generally dealing with a lot of material properties, And then,
Yep.
obviously more on the structural mechanical, sort of the strength side of things, but adding into the thermal characteristics, which is more tuned in towards the building physics of Passive House, it was just like another sort of add-on to it. And it was,
Yep.
I see it as a good marry-up, where the two are naturally sort of positioned to sit with inside of themselves, where as an engineer,
Absolutely.
we're used to working with the physics and the mathematics and the computations around, working with the material and how things are moving around. And Passive House is no different. Realistically, it's you're talking about thermal energy performance on a building. So
yeah, very good. Hey, well, thank you for your time, Brett. Really appreciate it.
Right.
Great to chat, and we'll keep in touch. Hopefully, it won't be too long before the borders open up again, and hopefully we'll still be able to have the South Pacific Passive House Conference at the end of the year. Looking forward to
it. Would be nice to be
catching up with everyone.
Looking forward to that.
Yeah,
October, I believe we got it scheduled.
Yeah. So hopefully at least the Trans-Tasman travel might be allowed by then. If not, I guess we'll be doing it virtually.
Yeah, which we'll see how it goes. But
yeah. But no, awesome to chat. I really like that. I did engineering as a mature age student after a couple of other short careers. And at the time, I did natural resource engineering because I was looking at doing something in sustainability. But looking back, I've often thought that if I knew then what I know now, I would have done structural engineering. Because of the influence that structural engineers have on the envelope of the building, which I didn't really appreciate. I just thought structural engineers built bridges and looked at, got excited about the size of metal beams and concrete. But I've realised that structural engineers can literally make or break
anything
a building in terms of its performance.
Yeah, very true.
So, Anyway. So it's great to find people like yourself that are doing it.
Yeah, no worries. Well, thanks for this the talks and it's good hearing about your business as well.
And that was Brett Seriani, who started out in Vancouver, British Columbia, but now has his practice in Melbourne, Victoria, in Australia. And I've often thought that if I had my time again, I would like to be a structural engineer because I've had a feeling for a while that structural engineers can make or break literally a building because structural engineering is deemed appropriately as really, really vital to the building standing upright. But it also is often where things like thermal breaks get introduced into the building. And I think it's so great to have people like Brett who have that engineering expertise, but also the interest in a passive house. So we can actually design really good structures that are also appropriately insulated. So really exciting to come across people like that. What was your takeouts from that one, Zach?
I totally agree with what you were just saying, and there's both the operational carbon implications of structure, like the thermal bridging and making sure we're breaking those thermal bridges, as well as the embodied carbon implications of structure. And so I'm really interested to see his thesis once it's complete and read that and glean his insights from that. I was just reading that for many buildings, the structure of the building makes up 80% of the embodied carbon of the building. So it's a huge, huge impact. So if we can figure out how to bring that down through using engineered wood or other options that he discussed in the interview, plus do it in a way that is conducive to the performance of Passive House, then we're making major progress on embodied carbon and in operational carbon. And I think that I think we've talked about before this really we really need to challenge this notion that this is an either or proposition. We need to figure out how to do both.
You can still have your balconies and have a complete thermal envelope. And we have the technology to do that. In the past, we would have just stuck a big hunk of metal to support a cantilevered structure. But we can still have the architectural flair and the beauty and the amenity of having things like that. But we have technology and products and ways of doing that now that we can have a complete and relatively unobstructed thermal envelope while still having some of these more interesting design features.
Definitely. I was also struck by how well he communicated the aha moment that he had and I wrote it down, so I'm going to say it again because I thought it was so good. And he said, when I heard it, it was like a light bulb that went off. It's the way that the buildings and structures should be designed. It's based around physics. It's based around proven methods. It's tested. It's not a checklist on how to do something in a sustainable way. It's actually tested, and it's a proven method of doing it. And that just resonated with me. It's brilliant. And I just got on the journey ever since. And I think that is something that so many folks who've been introduced to Passive House can relate to. And I really appreciated that he was able to encapsulate that so succinctly and eloquently.
Yeah, I've heard a number of people say similar things when you describe the outcomes of usually a passive house, and people from outside the industry kind of look at you and say, "Well, yeah, isn't that what a building's supposed to do?"
Right.
And I think often we get distracted by those of us in the industry by all these other things, and we end up with buildings that just simply aren't performing as they need to be, and then we get drawn into thinking that that's the status quo and that's what it has to be. So I think it's really great to step back and think of what the purpose of a building is and what it should actually do for itself and also for the occupants inside the building.
I agree. And with the challenges of climate change and the wildfire smoke, bushfire smoke that it brings, and the hotter temperatures, we need to figure out how to adapt to these changes. We also need to figure out how to mitigate and reduce greenhouse gas emissions, right? So we need to do both. And at our fingertips, we have the means to do that. And Passive House provides the means to do both of those things.
Absolutely.
To create resilient structures that create healthy environments and also that reduce greenhouse gas emissions, and that can complement things like New York State's climate goals, or just to choose one jurisdiction, or to achieve LEED Platinum status or Living Future status. So it's just that we have the tool to meet the goals. And as those goals and targets become ever more urgent to achieve, I think that that Passive House design and passive building principles will become more and more relevant.
Totally. I'm pleased to know that Brett has come along, and I think he's quite a regular at the global happy hour with the Passive House Accelerator. And so it's great to have people like that. And it's also just a reminder that it is global, truly global, and to get people from all parts of the planet sharing ideas and talking about their journey, and also getting really inspired as well. So shout out to Brett. Thanks for being there on that and contributing, but also, I guess, a reminder for people to jump online. If you haven't come along to that global happy hour, then check it out on the Passive House Accelerator website.
We have a great community of folks who come from New Zealand and Australia to the happy hour. It's really wonderful. Yeah.
Well, it's good. It's a relatively good time for us.
Yeah.
It's lunchtime. So while you guys are drinking beer, we're probably not, but having cups of tea and coffee. What else we got coming up at the moment, Zach?
Yeah, well, 2021 is in full swing. So at the Accelerator, the Construction Tech Tuesday, or Wednesday for New Zealand and Australia, this week, Tuesday, January 19th, will feature Emily Rea and Lindsay Elton of Eco Achievers. And the title of this presentation will be The Red Door of Truth. So it's all about the role of blower door testing and in construction practice for a high performance building in a passive house. So really
was it last week? Was it last week we said don't fear the red door?
That's right, and here we are, the Red Door of Truth.
Yeah,
and we're all about truth these days, so we're very happy.
Yeah.
And then on Wednesday we'll have Lois Arena, who was just featured on last week's Passive House podcast episode. Lois will be presenting about her lessons learned around VRF systems. So the VRF systems, particularly in multifamily buildings, and there are some really important pitfalls to avoid that she's going to be sharing from her experience. So definitely don't miss that. And then NAPHN has a ventilation symposium that's coming up at the beginning of February. FIAS has a bunch of trainings. There are trainings all around the world right now. So we'll share information about those in show notes.
Awesome. Lots going on. Lots to get involved with, and lots to be inspired by as well. And we've got more great interviews coming up to share with you. And we'd also love to get your feedback as well, or ideas for future guests, because there's just so much happening out there. So you can get in touch with us at podcast at passivehouseaccelerator.com. We'd love to hear your thoughts. And also, if you have a minute, don't forget to rate us and review us at Apple Podcasts or wherever you listen to this podcast. That's it for this week on the Passive House podcast. Thank you very much for listening in, and we'll be back again next week.
All of the work of Passive House Accelerator, including the Passive House podcast, would be impossible without the support of our sponsors. So we want to take a moment to give a hearty thank you to our sponsors. Our founding sponsors are 475 High Performance Building Supply, Baxt Ingwe Architects, Glavel Foam Glass Gravel, Minotaur, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Stocorp, and Zola Windows. Our stakeholder partner is NYSERDA, the New York State Energy Research and Development Authority. Thank you.